All right, in this video I want to take a look at how I think about parametric equations without actually doing tables. Okay, so I have this file that animates for me. There's three graphs down here, and here's what they are. I've got a set of parametric equations. Here I have x equals -1 plus t squared, and y equals t cubed minus 2t. The graph right here is y versus t. So the y-axis is going up and down, and the t-axis is running horizontally. So you can see that's this cubic. It's got intercepts at I guess it must be the square root of 2 and 0 and minus the square root of 2. Also, I have over here the graph of x versus t. Now this is tipped sideways, so the x-axis is running this way and the t-axis is running vertically. I do this because the way I think of this is that I'm going to draw this curve here. This is the parametric curve. I'm going to draw it by letting my feet be governed by the x-axis. That just tells me how far left and right to move. And my hand be governed by the y equation here. That tells me how far up and down it needs to be. So this graph right here is telling me, well, I'm graphing from between -2 and 2. So t starts at -2 here, and it'll stop at +2, -2 to +2. It tells me through this stretch, I'm looking at my x graph here. It's a parabola that's shifted down 1 on the x-axis. So. And again, remember, this is sideways. You've got to kind of tip your head sideways. The x-axis is running this way. So as my parabola shifted 1 in the negative x direction. Okay, I'm going to start up here at 3, dip down to 0, and go back up to 3. Okay? So just thinking in terms of left and right, there's a red graph. This red line is going to slide over to here, and then it's going to go back again. At the same time that that's doing that, the y value, the up and down, is saying start down here at -4, go up to about 1, come back down to -1, and go up to what is that, 4. So while this is sliding left and then right, this is going to go up, down, up, right? And I'm going to set it in motion here, right? Focus just, let's say, on the red line here. Watch what it does. Starts at 3. Oops. There we go. Let's start again here. Starts at 3, goes down to 0, comes back up to 3, right? And then I'm repeating the process here. But the idea is that red line is being only governed by the x coordinate. The formula right here is telling you what the x is doing. Now, focus on the blue line here. That's telling us the y coordinate. It's being governed by this curve right here, right? For each value of t, I'm figuring out what's the x coordinate, what's the y coordinate, and plotting that point. In a way, these two graphs are my table. That is, for each value of t, I can figure out what x and y are. But I see the whole process by looking at these two graphs. I can see that x is going to slide left and then right. At the same time, the y graph is going up and then down and then up. And so the whole graph should do that. I should be sliding left and then sliding right for the x coordinate, right? At the same time, the y coordinate is going up and then down and then up again, right, to draw this graph. So this is the way I think about these graphs, particularly on one like this where eliminating the parameter is particularly nasty. You know, solve for t here or solve for t there, neither one is particularly nice. If you try to do it here, you at least could add the 1 and plus or minus the square root, I guess, and then you plug a plus or minus square root in there. It's not going to be pretty. But notice, this is not a, y is not a function of x here. There's places where you have, two y values for the same x. Likewise, x is not a function of y. If I tried to solve for t here and then plug that in, this is cubic in t. There's places here where for the same y value, there's 1, 2, 3 x values. So, trying to eliminate the parameter to see what the equation of the graph is not always practical. However, looking at the two individual graphs leads me to a pretty good idea of what the graph of the whole thing looks like. Okay. We'll look at several more examples in subsequent videos.